Hello and welcome everybody. As always, my name is Eric Ritchie from Autodesk. Today we've got a special guest with us. We've got Mark LaBelle from SSOE Group. We're going to be talking about simplifying point clouds. So we've gotten a lot of feedback that people are working with big projects. So the question is always, what can I do to kind of break things down? So Mark's going to walk us through his process that he uses at SSOE. And I think you guys will really enjoy this. So for the session today, as always, if you have questions, we'll save some time at the end to answer questions, but, go ahead and enter those at any time into your little widget that GoToWebinar gives you. And the session is being recorded. We'll be posting this up on YouTube to, for anybody to check on later if you couldn't make it or anything else. And always, feel free to reach out to us. We'll post contact information for Mark as well. But, if you have feedback about, these sessions or have ideas, maybe you'd like to present at a future session, feel free to reach out to that recap.community@autodesk.com email address. And then this is just a list of, some of the other places you can find information about us, our social media channels, that YouTube channel that we're posting this video to, etc. So with that, I'm going to kick things over to Mark. Good morning, Mark. Welcome.
Good morning, everybody online, and those that are in the room here at SSOE with me. So as Eric said, my name is Mark LaBelle. I'm with SSOE Group. I'm out of our Toledo, Ohio office, technical leader. So not only myself, but there's many others that have contributed to this process at SSOE of understanding how to work with laser scan data more efficiently and break the data up into smaller chunks as we move it around our offices. So hopefully everybody finds at least one nugget of information that's valuable today, if not the entire presentation. So one thing I like to kick off when I've done this presentation before is laser scanning. I can remember the first project that we did at SSOE, at least that I was involved in the plan, was me left on the bicycle, and at the end of it was that nice checkered flag. It was going to be super easy, and this was back in 2008 when the tools were very, very crude. And the reality of the project was more of this. And really the reality of using laser scanning on a lot of projects is this, because each project does have its own uniqueness. So some of the tools I'll show you today are going to be based off of maybe more of an industrial or an open type of warehouse or factory. May not work completely, at least the way we structure or break up our data, maybe a life and science, a healthcare facility, but it will give you the idea to be able to put it into that type of a workflow. So I would say any given project, there's always at least going to be the little dip in value, but at the end of the day, we still do get to the checkered flag, and a lot recently it is getting more towards that top plan. We're getting back into, every time we've done a laser scan project at SSOE, now it's getting a pretty smooth line because of a lot of these workflows. So as an organization, where are we now? Why are you listening to me specifically about laser scanning? Prior to May of 2014, we had a few projects that we scanned per year, maybe 5 or 6, various sizes. Over the past 14 months, though, we've spent over $500,000 scanning facilities and projects for our clients. That's just our spending. There are other people that we work with, joint venture on projects, that have spent a lot as well. So sounds like a pretty impressive number. 50 projects, that might be it depends on size. So really what I think is an impressive number of the scale of laser scanning that we've done, the construction value is now north of $750 million. I think it's edging a little closer to $1 billion in the past year on the projects we've done. So I think that really kind of shows, because you can do 50 projects, but if they're all a 5,000 square foot room, it's not really that many big projects per se. So what changed? Why did we adopt laser scanning or reality capture as an organization to be kind of a standard of practice or standard of care for our clients? And I'm not saying this because I'm on an Autodesk webinar. I've said this in multiple other presentations I've done. I've said it in conversations with other competing software companies. one software has changed the game for us, and that's Autodesk ReCap. Autodesk did have a point cloud engine in their software prior to that, but the data didn't work very well. The architecture of it was a little rugged still for the times, still big. It was slow moving across networks. Design platforms, it just really didn't work well with us. So we really kind of bought into the ReCap system as initially when it first came out because it worked so well in comparison to anything else we'd seen in the past. And as it's become more mature, we're doing obviously a lot more scanning now because of it. So what applications are used? Oops, my transitions came in a little corny. Pretty much the entire Autodesk suite, Navisworks, Revit, ReCap, and ReCap 360, including the web product. We're using Plant 3D, Inventor, Civil 3D, AutoCAD MEP, and AutoCAD. So all of those particular projects or products we've used with the point cloud engine of ReCap. Also on other projects, because we do work with clients that do force us to work into other design mediums, we have used the Bentley point tools, as well as Bentley MicroStation, the V8i platform, and the XM platform, including Qubit Point Sense Plant to do creation of point clouds into modeled objects. And that's one thing I want to mention. Initially, when we did a lot of point cloud, when we had scanning or reality capture done at SSOE, we focused a lot on converting the elements, converting those point clouds to an actual geometric element so that we could still show it as a 2D CAD file or a 3D coordination file. Today, what we're going to show is really we focus on modeling minimal amount of point cloud information because it's not a value add to our clients. It's not a value add to our total project delivery. It's also just a very high cost for us to do because there is no value add to it. It's not something the clients want seen and built to them. They want the client or the project done as successfully as possible, and they don't need to see extra run-ons and such. So one of the things that's called for simplifying is how do we get data to another office fast? So a little bit about SSOE. We're an international firm. We have roughly 30 offices across 7 countries. So we're working, as they say, chasing the sun. We have people working 24 hours a day on projects. So we have to make sure that the data is able to get from point A to point B. Everybody can see it, and not just one office can see the point clouds. Everybody else has to imagine where the point cloud is. So sadly, I still have to say that we have to FedEx drives across the country. We haven't had to do it internationally yet. We still rely on it, but that's usually, that part of the process is when we get the data directly from our scanning vendors. So SSOE does not do any scanning yet. We do have some hand scanning technology that we're using as a supplement to our jobs, but big projects where we're doing warehouses, where we're doing our facilities, outside, inside, drones, or whatever, we're contacting a list of vendors that we have, and it's a pretty sophisticated list and growing. So usually they're going to send us the data directly via FedEx. Once in a while, they'll send us Dropbox on pretty small projects, usually 10 to 15 gig of data or less. Anything bigger than that, we just say FedEx it. It's going to take 24 hours to pull it from the cloud. And speaking of the cloud, it's kind of a corny picture of everybody gravitating towards what the proverbial cloud. But this is where we host data. So one of the things that we do at SSOE when the client allows us, because not all clients still trust the cloud or allow their data to be stored there, is we are actually hosting ReCap data through the ReCap web services. We found this to be a very robust system. We don't have to copy the whole point cloud across from one office to another or put it on a drive and send it to a contractor, a sub, even the client, and try to teach them complex software they need to download. We put it in the web, we give them a link, they get in, and everybody's commenting in real time. And we've had some successes recently with some projects. And I'll kind of show a presentation of a project. I can't show all of our projects because they're either in construction, confidentiality, etc. But for those in the room at SSOE, we can talk more about other ones internally. And the last thing that we use to get data to another office fast is the Iridium Q36 space modulator. That is an SSOE specific thing we designed, and I'm joking for those that know me. Really, the back end of our system is the strongest point of getting data from office to office. So We use Riverbed technology in each office to basically copy the deltas, which when you're copying point clouds for the first time, Riverbeds don't really help you accelerate. But every time you copy that file the next time, maybe you made an edit to it, you made it smaller from some of the processes we'll show, that does help. Also, you have to investigate in good server infrastructure. I can't stress that enough. If you're running old hardware, you're going to get bad read-write speeds. I could tell you that we're running on RAID 6 arrays on our Dell vaults, that they do get the maximum throughput of 110 meg per second from internal server infrastructure down to the client machine. From client to client across the office, obviously the bigger the pipe, the better. Some of our offices, we have up to 100 meg. And a lot of our regional or smaller offices were kind of between 7.5 to 10 meg on an MPLS line, not a bonded T1. So that does help. It does make it worth it. I mean, it is a little bit more pricey, but I can't stress enough that without that infrastructure in place, you're not going to get something to point A and point B fast. And that really has helped us. For instance, one of our larger projects where we had over 100 gig and we had to copy that data, and that's 100 gig edited. And you'll see what I talk about edited in a little bit. It took roughly, depending on the office, the better offices, it took less than an hour to get 100 gig, and that was halfway across the country. We had a closer office with a less of a line, and it took about 18 hours to get it there. Still faster than FedEx. So we can still get stuff overnight during working hours within a 24-hour span. And we've even copied some data all the way over to our India office, smaller chunks with pretty good success. So using these methods will help you as well as with a strong network connection. So a little bit how we work. Storage setup, large projects. So anything that's over 50 gig. And what I mean by 50 gig is not the raw scan data or even the raw scan data put into RCP and RCS files with the real views. I'm talking edited data. What is the data that you're going to reference into your design models? So anything larger than 50 gig, you have a second hard drive. It has to be an SSD. I mean, if you put a fast Raptor-based, classification of drive, it'll be nice, but an SSD is really where you get your improvements with point clouds, because most of what point clouds are doing is basically beating the living tar out of your hard drive. So that's what you need. Use a robocopy routine. Robocopy's been around forever. If you don't understand or know what robocopy bat file does, you can just do a quick Google and you'll get hundreds of thousands of results. Pretty simple. Just write a copy from source to destination, throw it on a timer. Smaller projects, anything less than 50 gig. This is the majority of our projects because of ways we edit the files. They work directly from the network. So we copy it from location to location, and they work from it in unison. So both drives, it is key that if you do have a secondary hard drive on the computer, that when you set up, let's say, for example, Revit, and you map to a physical drive of a P drive, that you have that same mapping for the secondary hard drive. Otherwise, when you pull the Revit file up and it looks for the point cloud data, it's not going to be able to find it directly from that secondary mounted drive. In addition to that, so what we do is we use Microsoft DFS to create a point cloud directory in each office. So not each office is mirrored. We're not using the mirroring technology because some offices have less storage or less people working in it than others. It is a targeted, if we have client 1, project 1 working in our St. Paul office and also in our Toledo office, we copy it to both of those. Otherwise, none of the other offices in our network would see it. If the P drive doesn't exist because of DFS, so let's say we have somebody working on the job temporarily for a day, because of the way DFS works is a failover, it goes to the next closest office in the network. So let's say somebody steps in from an office just for one day, they would fail over to where that location is. So they still can see it as long as there's no P drive in that office. In addition, running robocopy routines to run as a server task to manage the sync data between offices that need it. So that way it can cut over during working hours. If it's a high bandwidth copy, a lot of data going there, we don't want to saturate the office and make them unable to do actual real work. so the robocopy routine can stop. As we had mentioned, ReCap 360 Web is utilized for our non-modeling staff. So that's the big piece right there that we talked about with the cloud. Anybody that's call them a discipline lead, an engineer, a senior architect, project manager, director, whatever that may be called in your organization, as well as anybody outside the organization, we're utilizing that is the main communication tool. So simple network diagram to kind of understand it a little bit better. At the top, you have a modeler workstation that's connected to your network or your servers. Files are copied from that P drive on the server directly to the P drive on the user's machine. Anytime an update's run, the person coordinating or quarterbacking the project lets everybody on the team know, run the file. Then they reference anything from AutoCAD, Navisworks, Revit, etc., directly from that localized drive. And you're getting probably a 10 times performance increase in doing such, maybe larger depending on the robustness of your network. Non-modeler workstations, so these are, like I said, the project directors, PMs, etc. They're referencing data directly from the P drive. We're not going to make an investment of putting an extra hard drive in those people's machines. I would not suggest that you do that in your organization unless you have a really awesome IT budget. And if that's the case, maybe you guys can share with us. And that's because they're calling it up from Navisworks. Anything else, they're going to utilize ReCap 360 as mentioned below. The stakeholders are going to look at 360 Web. So as it mentioned in the bottom there, data is copied between offices during off hours via robocopy. Small projects, less than 50 gig, you knock out basically the middle tier. So everybody references the P drive, doesn't matter who you are, PM, workstation director, modeler, everybody basically that has some visibility into the project is just going to reference directly from the internal network. And the stakeholders go directly to ReCap Web. Now, obviously, if a project has sensitive client, doesn't want to go into the web because of IP concerns, one thing I will suggest, we do have Autodesk as a partner with us. They don't just provide software to us anymore. They are a partner to SSOE. We've worked with them on key clients on actually changing their tune about not storing stuff in the cloud. So I would suggest if you have a client that might seem a little stubborn or just doesn't understand, Autodesk is there to help you get those clients moving towards using a cloud-based solution. They have the people, they have the legal team, and it's really great service they have provided for us. So really the meat and potatoes of today, how do we make projects small? So we're getting pretty close to the end of the PowerPoint, and then we'll start doing a real demo, hands-on demo. But one of the first things I want to mention is make sure that you always edit the data on a local hard drive to the workstation. I've learned this because it was terrible. Never ever edit directly off the network. So copy the files directly to that second hard drive if you have one. If you don't have one, beg your IT department. I mean, you can get a solid state, Samsung solid state, 150 or 250 gig drive now from like 150 bucks on Newegg. You know, they're nothing. I mean, you're going to spend more hours waiting for something to happen than that 150 bucks. So it's really a big and significant investment. Second point, as it said, make sure to get that SSD. The third point when you're editing is make sure your ortho is set in ReCap. Otherwise, kind of hard to visualize, but we'll show it more with the perspective, but you're going to clip more points that you don't want to if you don't have it set to ortho. And the last point on this particular slide, make sure your data is unified. And what I mean by that is when you have your scanner and you take 60 shots in a project, each shot creates its own RCS file when it's converted into Autodesk ReCap. If you start chunking up or splitting data into sections without unifying all of those RCSs into a single one, it's going to take that process of exporting and it's going to multiply it. I don't know what the multiplier is. It's not necessarily exponential, but it certainly is a lot longer. For example, a project that we did where we learned this unknown feature of it taking slower, we actually edited the data, chopped it all up, and once we did the export, one export of a floor, and we'll talk about the floor thing in a moment, took 48 hours. reunified the data. So I took all those RCSs, unified them as one. That took like 35 minutes to run. Once it was unified as a single RCS file, and then I did an export of only the floor feature, it took another 35 minutes. So in an hour, I was done. The other one I had to wait 2 days. So that's the key there, is making sure that you have a single RCS file from a technical perspective. The last 2 points, export data when you get the spinning wheel of death. I can't explain it other than you'll know when you get it. Probably a lot of people that are on the call have gotten it before. And I know I follow one of the forums or the threads. I think I was either one of the first 2 people to post on it about the spinning wheel of death. And really, just as soon as you keep putting stuff into a region and you get that spinning wheel of death where it starts spinning longer and longer, as soon as it takes, let's say, 15 to 20 seconds to place something to a region, just do yourself a favor, export everything as is, and then restart from that exported data set. Once again, like in my previous example, 48 hours versus an hour. It's the same thing. If you keep regioning up, even though you have the spinning wheel of death, that export will take. I had one export because the guy just very, very wanted to keep putting stuff on there. It took him almost 3 days before we finally canceled, and it was only 20% through the exportation process. So that's why you want to do that. And also have 2, if not 3 or 4 computers to do your post-processing. So when you save your RCP file that you're doing your regions, you copy that RCP file with the RCS files to that other computer over the network, and then you can start doing multiple exports. Really will start changing up your time and getting data to the users faster, because it never fails. As soon as we get a project, they got to scan it, and then a week later, we got to be using the data, and we have 30% review the week after that. That's just how projects are. Until we can find a client that just wants to give us all the time in the world to design a project, we're never going to have the ability to, tell the team to wait to get their hands on the data. So having multiple computers to be able to post-process is huge. So here's an example of a top-down view of our, let's call this just it's an industrial warehouse and manufacturing facility. You're looking directly at the roof. You see none of the components directly under it. So this is what we would see directly from the vendor. Just one, this is like 4 bays by 5 bays scan. And this is typically what you see a lot of people, referencing to said CAD platforms in the earlier slides. And what happens is, one, this data set, in this example, this is only one, call it section of the building. This was 6.5 gig. The entire building was about 250 gig when all scans were said and done. When we broke it up, so here's a picture of what it looks like post-edit. So we removed the floor, we removed the equipment, we removed the roof deck. The data that we cared about was this slide only. So basically the utilities, the structure, and some of the walls. That data right there was about 1.2 gig. So if you're pretty good at math, it's about a 25% reduction, or 75% reduction of file size. 25% is all we need to keep. So when it comes to pushing data across your offices, you only need to push the 25%. Now there's not a magic button that says give me only 25% of my data, but I'll show you how to kind of do the magic button with a couple of tricks here in a minute. And lastly, what I want to show here is the demo plans. So a workflow that we talk about is demolition of point clouds. This is actually what was issued on a project. We took 3D views along the left-hand side from ReCap. We saved them as a JPEG, annotated them in Revit, and took a straight orthographic view of the point cloud, because when you flip your 2D plans, it turns into orthographic. That is a point cloud that is referenced directly into the sheet with annotations for demolition. Same thing was done for our engineering documents. Point cloud was the reference. We didn't draft up or model up, but barely any existing features. And that was only because we were tying existing systems to them and needed them there. So here's a video, and I'll put it on repeat to kind of talk about it, but this is that particular process. So anything in yellow is just how we're chunking data up. So you see the roof disappearing, the floor, and then the green that you're going to see disappearing is actually the stuff that we identified as demolition. So that was the lights, the fire protection, and now you're seeing the actual designed elements coming in. So the one thing we did mention that we modeled was structural columns, because we need to shore up steel as well as support stuff overhead. So that should repeat one last time here. And it's got some techno feed in there if there was actual audio. So last time, so everybody can kind of see it again. Anything yellow is how we were cutting it up or chunking it. So that was all the stuff we were removing. And this was because of to create our plans as well as a better coordinated file set. Green is demolition, so it's a little bit harder to see, but the lights show it pretty well. Piping and mechanicals, and then all of your design models start showing up within your point cloud. And this is a real world example. This is not a laboratory experiment. This was a project that we issued. I wish somebody was here from the project, but I want to say it was like, by the time we got laser scans, I want to say we were done in like 2 months with construction documents. That was about 300,000 square feet. So when it comes to doing point clouds, the pluses and minuses of RCP files when you're referencing directly into your CAD software. If you're working with small files, let's call it 2 or 3 gig raw data, or just maybe you did, let's call it a electrical substation or something like that, and you only had like 10 or 15 shots out there. You don't really need to go through the process of chopping stuff up. Yeah, it's nice, it's convenient, but the data is so small, it's not a big deal unless you're trying to get that 2D print set. So the RCP file, in that case, it saves time for exporting, because you don't have to do one for each region. You just create your regions directly in the RCP. Now you reference that directly into your software. Now the minus with that thought process is Navisworks and Revit do not recognize regions within RCPs yet. So you did all that work, but you don't see it in those 2 software platforms. And anybody that's doing a lot of 3D coordination really quarterbacks or relies on Navisworks to do that. So you probably got to spend time, unfortunately, exporting them. Now that time, once again, a project example, 400,000 square feet, we had 1 person working on it, and they were done in 4 days. They had 2 computers chunking up data. So it doesn't take too long if you have the right resources and staff. And we have trained, I want to say, maybe 10 to 15 people internally on how to do this process. So we're getting pretty good at it. The plus also is regions can control visibility in AutoCAD and ReCap. So that is a nice thing when you can turn things on and off very quickly in those programs. Now, once again, I would suggest that you stick to smaller sizes. Once you start getting like a 5 or 6 or 7 gig point cloud and you're doing regions in there, we have noticed some performance decreases in Plant 3D and any of the kind of the 3D based AutoCAD platforms. Also, a point of note, for us people that are in ReCap all the time, regions make sense. We understand what they are. They're like layers in AutoCAD or work sets in Revit. But for people that don't use ReCap, your modeling folk or anybody else, they don't know what a region means. It's just another education point, another point of confusion. So if you just take the time to export the files, it's a lot easier for them to understand. Turn the file off, everything's off, not go inside the file, turn off the specific regions. And also, regions still process data while loading, so it doesn't really help your model load time. So when we're talking about chunking files up, we're not loading the roof, we're not loading the floors, we're not loading the walls in Navisworks potentially, because it takes that much longer to open up the model. So regions won't do that for you if you have a RCP referenced in. So tips for breaking these things up. How do we do it? Well, we take it as a plan of attack as part of our project. We don't get the files in and just start breaking it up based on a previous project. We sit down, we talk with the team. What's the scope of work? What are the deliverables? How are we really going to work and manipulate this data? Because the one thing we found with Revit is, and this is why we started removing roofs and floors, not only to create 2D plans, because you can do that when you have the whole thing, but crop regions, when you have lots and lots of crop regions with point clouds, the performance goes down really quick, real fast, and there's nothing worse than a modeler that hates Revit for no reason other than point clouds are dragging it down. So that's one of those things you need to, as a kind of a tip. Create a work set for each point cloud model that's referenced, so they have the ability to turn them off quickly without unloading the data or unloading the entire building model per se. Also create an NWF, so in Navisworks, make your master NWF for point clouds only. So when you have your, call it your Revit models or any of your other design models, you can bring that NWF in as an attachment. It brings everything else in there. And clash detection, this is the note that we've recently come across. Clash detection only occurs when the point clouds are visible, so put that in the notes. If you have your point cloud hidden when you run clash detection, it'll show that there's 0 clashes. So either you have the best design project of all time where you didn't hit anything existing, or the point clouds were hidden, and that's what happened for us. So finally, get into the product a little bit here, and talk about how we do stuff in ReCap. And one thing I'll reach out, Eric, was there any questions before I go into that?
I think we're looking pretty good right now. Like I said, we can definitely save some time at the end, but I think people are pretty engrossed right now.
All right, well that's good. Autodesk ReCap. All right. So let's hide that go to meeting. I think we can still see ReCap. So right here we have, this is a small subset. This is of one of our 300,000 square foot scan projects. Total data, as I said, was about 250 gig. This was project RCP files with real views and RCS. So what I'm going to do is start off with the process how we normally educate our users here at SSOE. So you turn up, or first thing I always tell them is create scan regions based on how we're going to level or section things out. So just go through in bulk, create a scan region. First one I'm going to create is, we'll just call it roof, and turn it off. And the reason I say turn them off is so as you start assigning stuff to a region, it just turns off and you don't accidentally put it to another region. Put my floor, we'll create my equipment, and then structure, I'm just going to leave that as not being on region, because that's my final export. So first things first, I always go for the easiest, which is usually the floor. So I'll turn it upside down, take my plane, usually to a 50 millimeter on a pretty flat surface. I know there's a lot of ramps and stuff like that in projects, so that might not catch the entire floor, or if you do a plane on a ramp, it's going to shoot that plane up through equipment, so that's always a bad thing. But I'll just pick 3 or 4 points here. Actually, I picked more than that. Hit enter, and then I'm going to hold down, because it didn't pick my entire floor. I can tell by the striping over here in the upper, or kind of more the right side of my screen. So I'll just hold down my shift key to add more points. Hit enter again. Still missing a few. That's pretty good. Might be missing some there, it looks like 2. All right, so that's a pretty good floor. I hop over to my region stack, and then I go ahead and assign this to my floor region. So, all right, floor's gone. You can already start to see no floor. Let's kind of go ahead and do the same with the roof. Now, there's a bit more science. I usually get a little bit better because we have a 1-hour demo, about 20 minutes left. I'll leave a little bit of time for answers. I'm not going to get completely exact. Obviously, you want to make sure your roofs are, you're only getting the right roofs. All roofs have some type of slope to them, so you wouldn't select the entire roof. You can see that between columns, that's where your main pitches are. So I would only crop my view to that particular one. So I'll kind of show an example of what I mean by that. Let's go ahead and turn my ortho, my perspective off, look at it directly from a front view, and select column to column. You could also use a limit box to do this as well. Really, that's personal means and methods. I prefer using clip regions. Others prefer using limit boxes. So you can go ahead and do clip everything outside of that, and then you would just do your planar view from there. But I'm going to go ahead and do an unclip all for the sake of time, and just do a plane. I'm going to max it out. So I'm going to take completely the outside boundaries here just for fun. Take my depth up to 100, which is once again a little bit higher than I like, but oops, I forgot to do my plus. And get get you there. Close. And that's pretty good. So I'll assign that to my roof region. And then you're going to see the wheel come up. And when this wheel takes a significant amount of time, this is a pretty small data set here. It's not small, it's 6.5 gig, but I found personally when you start doing a lot of like fence type clipping, not planar stuff, but you start doing fences and planes and you start getting weird shapes in there. I don't know the exact number, but from personal experience, it seems like after maybe a half an hour of editing a file, assigning stuff to regions with using the fence tool an awful lot, it may create that slowdown. So I usually try to create nice, solid, square, rectangle type shapes or planes. I stick with those, less likely to get that particular slowdown. So the last thing I'm going to do is basically hollow out my equipment. So if I take a quick look here, I have a column over here on the right. There's a column here in the middle, and then there's one over here on the left. So what I'm going to use is my window tool to basically select everything inside the columns, which would be, and then below the truss. So everything, let's just call it this. Once again, not trying to get perfectly exact for a demo here, but give you an idea of how we do this. And we'll run this way. Once again, using Shift to add to the selection set. You can also use the Alt key to do a minus or a removal of your selection set. So it's kind of like your traditional CAD programs. Hover back over the region stack, and I'm just going to drop this on my equipment region. Now I just heard my laptop fire into hypergear here, so it didn't take too long. Now I can go ahead and spin my my point cloud to another side view, so then I can clean out between the columns again. But the one problem is if I do that, I'm going to accidentally select this wall, and I'm going to drop that to the equipment layer or the equipment region. I don't want to do that. So I'm going to spin back to the side, line up my view, and then just do a temporary clip so it doesn't select that as part of my equipment process. So I'm just going to do a clip inside so it removes the wall. Hopefully I got it all. Dang it, I didn't. Let's just do it this way. Clip inside. And now I can finish off my equipment editing here. There. Hold down my Shift key. And do it here as well. And this is the threshold of comfort, usually that I would do it started spinning a little bit longer there. But once again, like I said, working with about a 6.5 to a 7 gig file. So it's a pretty good size of data that we're talking about here. And this is where really we need to export anyways. So once that assigns that last piece, I'll flip it over on top so you get a top-down view. I think you get an idea of how I would export. So go ahead, look at the top-down view. That's my view. That's a 2D representation if you want to look at it from a 2D perspective for a sheet of, for your typical stick set that you might send for plan review to whatever agency you need to, constructor or whatever. So there you go. That's your file for coordination. At this point, all you would have to do is do an export. And then I always select RCS. Let's just call this truss. And then I set my settings down to 1. Everything else that I might need, like that floor, that roof deck, or the equipment, usually when I'm exporting, I'll do like a 30 millimeter. Sometimes we'll do 10 millimeter, depends on how crucial that piece of equipment might be, or the roof or the floor. But we usually scale that stuff back because we care less about it from our design process. Maybe we're ripping out the concrete floor anyway, so we really don't need much information about it other than it's there. And a point every 30 millimeters is still enough to identify the flatness of the floor for our perspective. So then I hit let's unify. I'm not going to do that for this process, and then it takes 5, 10, 15 minutes or so to do that export process. Once this file's done, I'm going to cancel this. Then I go ahead and just turn on the other regions and then turn off the structure region, and then export each one. So then you have 4, maybe 5 or 6 files, depending on how you're breaking it per scope of work. So to understand that, that's in recap pretty quickly on how we did that. Let's go to Navisworks now and show really how that works. So now we're in Navisworks. We're looking at the same 3D file I just edited. So that's L25 RCS, all one scan. So basically what I just demoed was, I'm going to hide this and turn on basically the sections of the regions that I created. So here's the 4: equipment, floor, roof deck, and truss space. So let's go ahead and turn those on, and you can see in Navisworks, when the points kind of regenerate here, everything still looks the same. Doesn't look any different. I still have all the points. Now they're just created in 4 different regions. So if I wanted to, I can just hit hide for my equipment, and now I have an empty shell of a building. Or I can turn my floor off because I really don't need to see that. Same thing, my roof deck comes off. So that's stage 1 of our editing process at SSOE. We get the data, we chunk it up, make it a little bit more palpable for our applications, and then we start creating demolition drawings from those. Once we get into the demolition drawing phase, we mark up, as you saw in that 2D representation with notations, specific items to get demoed as part of the process. Most projects, once again, don't have a luxury to rescan after demolition's done. We're done. We've already issued our CDs, and we're on to the next project before they even start ripping stuff out of a facility usually. So we can't come in and do a laser scan post-demolition because our drawing's already released. So what we found as a process, not only one, it helps us with clash detection and coordination of our routing, but it's also a value add to our construction partners, even if we are not acting as a construction partner, because we do CM as well internally. So on those projects, it just helps our CM side, but on the ones where we're in a joint venture or a design build or a bid build particular relationship, we hand the file off to them, and it's a huge value add to them as well. So the last thing we do, and I'm not going to show how we do that in recap, it's the same process, selecting specific elements like lights, like piping, like ducting. We'll show that just here in Navisworks. So I'm going to select my truss area, turn that on. This truss area is everything to remain, or existing to remain is what ETR stands for. The mechanical demo, the sprinkler, and the electrical demo. So I'm actually going to turn the truss existing to remain off for a second. Each one of these sets we export as its own RCS file as a just in case, holy crap, we demoed it, the contractor or the client changed their mind and said, no, we want to keep that now. It does happen. And this is just our backup, so then we can put it back into the existing to remain files to make sure we have it for good coordination purposes. So we do maintain a shell copy of each of those demos, and we still put them into Navisworks as potential coordination items, but they're almost always off. So as you can see here, I have highlighted right now just the entire sprinkler system for that particular bay. This is the mechanical demo. So this is any of the piping, support piping besides sprinklers, as well as the HVAC, drip pans, etc. And if I turn that off, you can see that what remains here is the lighting, some of the hangers for the lights, as well as the electrical busway that was being demoed out in this process. So lastly, I'll turn off that demo, and this is our final product. This ETR, all of that stuff is removed. So then we bring in our design models for complete coordination, as you can see here, and this particular, at least part of the facility, we have minimal, at least, scope of work, but it was a small enough data sample that I can at least show through WebEx or GoToMeeting and not be too entirely slow with the process. And one thing I want to mention is clash detection here. So another reason or another proof of why we do this, because it might sound like we're trying to maybe make a lot of work out of something to not get a lot of return. But once again, we're getting planned. We don't have to model stuff. That takes a lot of time. And also, when you look at clash detection and chasing your tail on looking at a set of demo drawings and finding what is really not to be demo or what is going to be demoed and saying, okay, that's actually not a clash. You know, we can keep our, ductwork there. These are 3 different clash tests that I've run just to show the numbers. The original is untouched data directly from the scan. That was that first file versus our design model. And that's just for this section of the plant. That's roughly like 30,000 square foot. The second one is when we actually sectioned up the data. The reason the number of clashes is higher because we do leave a little fuzz or overlap between those sections, so you might get duplicate points between those sections, so that's why you have a little bit higher clash. But the last one is 157 clashes for this particular area where the demo, this is the existing to remain portion of the project only. Everything that's been demo has been removed against the brand new design model that's going in place. Now, it might not seem like 120 clashes is a lot, but over the scale of this project, it was actually about 1,800 clashes was the difference between demo, clashing against the original versus clashing against the cleaned up demo model. So there's a big difference in terms of time spending trying to figure out those 1,800 clashes, looking at plans, sitting down and doing a whole plan review meeting, just because of that stuff. So it's a huge, huge value add for us, and that's kind of a little bit into the window. Let's see. Actually, as I switch back to my PowerPoint slideshow, I believe that actually takes us to the end. I actually had a little more time than I thought, so we have about 15 minutes or so, now 10 minutes for questions.
All right. Well, thanks, Mark. That was great. Just a reminder, if anybody has questions, feel free to keep typing them in. We'll try to get to as many as we have time for. As you can see, we've got Mark's contact information here if you want to follow up with him. As I mentioned, if you want to reach out to the ReCap team, to my group, we can, if you send an email to ReCap Community, we'll be happy to follow up as well. And then, this session is being recorded, so there's the YouTube link. So let's jump into some questions. So just trying to pick off some of these. So you were showing the plane selection for the floor, for instance. So the question is, when you're using that plane selection tool, and you're showing the shift click to add more points, the asker wants to know, is that adding those points to the original plane, or is it creating new planes each time you do that?
That's a separate plane of its own, but it's adding it to the region that I'm going to apply it to, or the selection is what it's doing. So to kind of think of it in more of a CAD-based workflow, if you have, let's say, 2 or 3 walls that you selected in your original selection, and you keep adding, picking one at a time with the wall, it's adding it to that particular selection to do whatever your editing process may be. For me, it just happens to be I'm assigning stuff to a region, but other people might delete the points, which I don't necessarily say is a good practice, but I have seen people do it where they delete it. So it's not necessarily adding it. It creates its own plane, but it's for that particular selection.
And similarly to that, if you click on something that's, that's well outside your plane, they're asking if that will be kind of thrown out, or if that then includes it in the plane.
It does actually. So the one thing I didn't show as part of the process is I always, because of the time we have here, I always make sure and rotate around after I select a plane to make sure it's not off at, let's see if I can get my recap session back up here, off at some crazy angle. Like I had mentioned with like a ramp. So if I did, where I clicked 3 points here, let's just do it for fun, but if you click 3 points randomly, it's going to pick it at that plane through that particular process. So you can see it has a weird angle. So you definitely want to not just trust the system, but rotate it around to make sure you're good.
Okay. Another one where we have a question about the origin. So do you set custom origins? Do you reset your origin for the project? Anything along those lines with the custom origins?
One thing I will mention, a slightly shameless plug, but I will be presenting in a much more deeper dive of this topic at Autodesk University. But to answer the question, that's part of it, but we generally don't reset origins on our projects. We specify an actual survey coordinate, whether it's a plant coordinate system where a column has, let's say, a 1,000, 1,000, or an actual survey benchmark in the field. That's something that we coordinate directly with our scanning vendor, that they put everything to that aligned system. Now, in the event that we're doing hand scanning, yes, we are actually applying an origin because we're not tying it in usually to any type of known coordinate system.
All right. Segmentation data. Have you used segmentation data at all from ReCap in, for instance, AutoCAD?
Segmentation data, not like chunking it up like we have here, I guess.
So segmentation data on the ReCap side, when you index your file, we create what we call segmentation data that allows you to set like break lines and section lines and stuff in AutoCAD. That's specifically AutoCAD 2016. I believe we added that.
Yeah, we currently are not on AutoCAD 2016. We will be in about a month. So okay. No, to answer the question, no, we haven't done that yet.
We do have a couple of questions about about the software you used to make that video.
Navisworks. It was a Navisworks timeliner sequence. I just assigned selection sets and timeliner sequence and exported to AVI, and then just actually use Windows Movie Maker to post edit.
All right. Here's one for me, I think. So we have a question about how the tools available in Memento overlap with the tools in ReCap. So like I said, I'll take that one. So what we're doing right now with ReCap and Memento, these are, for one thing, Memento is still in beta. If you guys are interested in it, go to memento.autodesk.com. You can download that for free. That's taking meshes. So most often, photo to 3D projects, but it'll also import, OBJs and other, other mesh files. And so Memento offers a whole suite of tools for working, with those mesh files at a very, large scale, high quality. So that one's still developing. A lot of the features, we're adding new things all the time. ReCap, we're focused primarily on the ReCap side on point clouds and giving you all the tools you need to really work with your point clouds and bring them into your workflow. Be it Revit, Navis, whatever. So that's kind of the high level differentiation between the two, is that Memento, the focus right now is really on the meshes and the whole workflow around meshes, and ReCap is, focused on, point clouds. So that's, not to take too much time, discussing all of that. We have lots of information if you want to know more, but just to answer that question, that's largely the breakdown. Let's see. We've got a question about Revit. So, bringing the point cloud into Revit. The question is, the display of the points seems to be pretty low quality in Revit compared to ReCap, and the questioner wants to know if there's a setting or something along those lines that will, did they miss something? Will that, is there something that can help that?
I'm going to be forthright. I'm not the Revit expert in our organization, so I would actually honestly have to punt to them. I know there are some settings in our view templates that they've tweaked a lot, and that might be something that if you send me an email, I'll throw my contact information up there again, that I can get you the answer to. But off the top of my head, I can't give you that piece.
Okay. Another question about, so you showed the unification and the decimation grid and all of that with the unified file. The question is all about, so you removed a lot of information, for what you had as the structure, the things you're keeping, what kind of what kind of I guess data savings, file size are you seeing from doing that unification and the decimation?
So depending on project, like I said, we might, decimate certain objects at a much higher rate. Like I said, 30 millimeters is our kind of our current standard on the stuff we don't care too much about. So the project that I showed there, the overall about 300,000 square feet of scan data that was originally 250 gig, the data that we were referencing in that ETR, that structure, the existing to remain, ended up being just a little bit over 32 gig. So, 75, 80% file reduction size that you're trying to load into your active modeling software, which is huge, huge savings in production for those users.
All right. We have a couple of questions about, you have the pipes and ductwork and all of that, asking whether that was just a lot of detailed selections in ReCap or whether you used a separate modeling package to create those selections.
That was all done in ReCap, actually. And that's why I mentioned earlier why we've done so much more now in terms of reality capture. We can take on more work because of the tool set and the simplicity of it.
And to add to that, the second part of that question is, with it having been done in ReCap, are there any tricks that you can offer for, selecting those large runs of pipe, serpentine routes, etc.?
So once we cleaned it out and you're looking at, let me share the right application here. Let's say, this Navis view, depending if it's a relatively flat pipe and straight, we'll look at it like you're looking right down the barrel of a gun. Straight on, make sure your ortho's on, and then you just do I prefer, as I said, the rectangular tools. Fence is good here and there, but try to use it sparingly, just to basically get within there. And then you can always deselect if you've selected too much before assigning that pipe to a demo region.
All right. And I think we're at time, so I'm going to see if we have one more. Okay, so there's one last question that I'll grab. Asking about taking these regions in ReCap and then exporting those as for instance a JPEG. No, that's not something that we have, that we're doing at the moment. If you have a compelling use case to attach to that, please reach out to us. We're always interested in, ways that we can improve and, add some additional time saving to people. So, for the person who asked that, if you want to reach out to us, I'd be interested to hear what your workflow is with that. But yeah, no, I think we're out of time. But thank you, Mark. That was great, and I thank everybody for joining us today. Feel free to reach out to us, as I said, Mark or myself, and we'll be posting this recording. So thanks for your time, everybody. Thanks, Mark.
Thank you very much.